Welcome back everyone. In this tutorial, we'll take a look at sending real-time live link animation data into Unreal Engine and applying that animation data to a character. We'll be covering a bunch of things, including how to set up Remap Assets, configure bone name remapping, and tweak live animation data with the animation graph. And by the end, we'll have a single live link source driving multiple character rigs simultaneously in real time, as you see here. So the first thing we need to do is make sure that the live link source is showing up inside Unreal Engine. Right now we're using Radical Studio, which gives you 3D human pose estimation data using your webcam as the live link source. I turned on the live streaming feature in Radical Studio, and then I'm going to go to Unreal Engine. To get to the live link setup, we should go to the window, then live link, and look for the one that you're streaming. Obviously, we're using Radical Studio, but there are many live link integrations for other software like Maya, Motion Builder, Xsense, and so on. So now that we have the live link data source registered inside Unreal, we can preview that using the skeleton asset. So since we're using Radical Motion Capture software, I have the Radical skeleton here, rigged using the mesh from the Unreal Mannequin. So this skeleton structure is identical to Radical Studio's internal skeleton that it's using for 3D pose estimation. This will just make it easier for us to preview the data without having to worry about compatibility with different skeletons. So if we go to the preview scene settings, we can select the preview controller as the live link preview controller, select our Radical pose as the subject name, and you'll see that there's some pretty weird stuff going on. This is because the live link data from Radical Studio has a unique structure that we haven't told Unreal about yet. In this structure, there is position data only for the pelvis bone, and all the other bones have only rotational data. But Unreal doesn't know that yet, and it's applying positions to every bone. And because an empty position vector is 0, 0, 0, all the bones are collapsing into the root. Now this is where the Remap asset comes in. Using a Remap asset, we can fix this issue by telling Unreal to only apply rotation to the skeleton's bones and leave position to the default value when the skeleton's in a T-pose. So let's open up the Remap assets and go over them. The ones I'm about to show you are pretty specific to Radical Studio's way of specifying animation data, but you should be able to get a general overview of the techniques and the different methods you can override. And this video should still be a helpful resource for creating your own Remap assets. So if we take a look at the header file, there is a few methods in here. The big one is the build pose from animation data. Now in this method, some of the names might be long and unfamiliar, but the logic is pretty straightforward. What it basically does is get a list of the bone names from our live link animation source and find the corresponding bone name in our target skeleton using the getRemappedBoneName function. Later on, we'll show you how to implement that function in blueprints. If we're targeting the Radical skeleton, the names are the same, so there is no remapping. But if we're targeting the Epic skeleton or some other skeleton, we will have to account for naming differences. For example, the hip bone for the Unreal skeleton is actually called the pelvis, and the shoulder bone is actually called the clavicle, and so on and so forth. Next, for every bone, we're going to find the bone transform as well as the compact pose bone index. I will put a link in the description for a more detailed blog post on what this is and what this is, but essentially we're going to just take the transforms, find the matching bone on the target skeleton, and apply location and rotation data to those bones. For the majority of the bones, we're only going to be applying rotation data. But for the hip bone, which is the bone in Radical Studio that actually gets position data, we're going to set location as well as rotation. Now let's take a look at these three methods here. These methods account for the differences in coordinate axes between Radical Studio and Unreal Engine. Radical Studio produces rotation values in OpenGL's coordinate system, which is right-handed and Y up, whereas Unreal uses left-handed and Z up. So we have to swap and invert some of these axes to get things working properly. For the asset base class that we're looking at here, we simply return the same value that comes in as a parameter. But in our child classes, you can see the specific modifications we do to get the incoming position and rotation data to match up with Unreal's coordinate system. So for our root position, we invert the Y. For the root rotation, and again, these root position and root rotation are actually for the hip bone, we invert the X and Z axes. And then same goes for the bone rotation, which covers every bone that's not the hip bone. In the radical to epic remap asset, we have slightly different modifications compared to the radical to radical remap asset. So here we actually swap the Y and Z axes instead of simply inverting. And then we also swap and invert axes for the root rotation, but the bone rotation stays the same as the radical to radical remap asset. And this is true in general if you're going to be creating your own remap assets to use with Radical Studio. You'll likely have to experiment and find out your own implementation for these methods, but the bone rotation will probably stay the same. So now that we've written our remap assets, we can set Unreal to use them by going to the skeleton and going to the previous scene settings as before, selecting a live link preview controller, the radical pose, and then the retarget asset. This is where we're going to set what we just wrote in C++. So as you can see, the animation is looking proper now. And this is just a test animation that I'm playing in the background as a loop. At this point, we've covered everything for targeting live link animation data onto the radical skeleton as a target. But for the epic skeleton, there are a few remaining steps before we can target that properly. First, we're going to revisit the getRemapped bone name method that we came across earlier here. Now I mentioned that you can implement this method in blueprints, so what we're going to do is hop back into Unreal. If you were to be using this on an empty project, you would need to create a new blueprint class and inherit from the rad to epic remap asset, but in this case we've actually already created it, so we're going to skip. Now if we open up the one we've already created, we can see on the left hand side that there are overridable functions. The one that we're interested in is getRemapped bone name, which we've already implemented, as you can see here. What this essentially does is get the bone name coming in from the live link source and do a big switch. And this switch is going to take every name that could possibly come in from live link and then map that to the corresponding bone on the target skeleton, which in this example is the epic skeleton. So you can see that hips maps to pelvis and so on and so forth. There are 23 bones in this switch statement, and they each map onto a target bone on the epic skeleton. Finally, we have to fix a minor arm rotation issue. This is because the Unreal Mannequin uses an A pose by default, whereas Radical uses a T pose. So we did some manual adjustments to the arm rotations to compensate. In the animation blueprint, we're taking the live link incoming pose and we're modifying specifically the upper arm, lower arm, and hand bones on each side and applying an offset value to the rotation to compensate. I derived these values by comparing the two skeletons side by side, writing down their local rotation values in a spreadsheet, and then subtracting the target value from the source value. From my personal experience, this will work for minor changes, but if the skeletons are too dissimilar, you're probably better off by simply re-rigging the mesh with the radical skeleton. As a case in point, you can take a look at my Mixamo work in progress blueprint, which is far more complicated and still has issues. Finally, to view our meshes in a scene, we can create a new blueprint, add a skeletal mesh component, set the skeletal mesh, add it to our scene, which I've done here for both the radical and epic skeletons, and then press play. If the live link source is running, we'll see the two skeletons side by side in our scene with matching animations. Thanks for watching. If you have any questions, please leave them in the comments and I'll try my best to answer. And if you enjoyed this tutorial, please consider subscribing to this channel and checking out some of our other videos on Unreal Engine. See you next time.